Last time when we left off, we were trying to build the basics in order to solve AMC 10A 2019 question number 24. And in order to solve that, we first looked at the Vieta's formula, and now we are essentially building our second step, which is algebraic manipulation. So here's an example for really good algebraic manipulation skills. And let me tell you, this is an example from AMC 10A 2019. So this question asks the least possible value of this expression, x plus 1 times x plus 2 times x plus 3 times x plus 4 plus 2019, where x is a real number. Alright. So in order to solve this, we want the easiest and the laziest method. So let us try to multiply out the binomials only, so that it does not take much effort. So let us start with x plus 1 times x plus 2. X plus 1 times x plus 2 is x squared plus the sum of these constant terms times x plus 3x plus 2, and this would become x squared plus 7x plus 12 plus 2019. Is it easy to factorize? I don't think so. And I want an expression that is really easy to tackle with. So I don't want this. Let us try another one. Let us try to multiply x plus 1 times x plus 3. So x squared plus 4x plus 3. And this is x squared plus 2x plus 4x, 6x plus 8 plus 2019. This is also not an expression I'm used to factorizing. So I don't think there is really good way to factorize it. Let us try another. X plus 1 times x plus 3. Let's do x squared plus 5x plus 4 times x squared plus 2 plus 5, 2 plus 3, 5x plus 6 plus 2019. This one looks pretty nice. We have an x squared plus 5x here, x squared plus 5x here. We can substitute that. Wow, nice. So let this be a. Alright. So then expression becomes a plus 4 times a plus 6 plus 2019. And now we can multiply this out. So a squared plus 4a plus 6a, that's 10a, plus 24 plus 2019. Now we are asked to find the minimum possible value. And one of my favorite tricks to find the minimum possible value is completing the square. Look this out. So this is the first term squared. The first term is a plus this should be 2 times the second term times the first term, right? So 2 times the first term times the second term. What's the second term here? Well, we can divide this thing by 2a and we find that the second term is 5. So the third term must be 5 squared. This is the b. So the third term must be the b squared. So that should be 25. And we cannot just add a 25 here. We need to subtract it so that we can balance it out. So we can subtract negative 25, or we can add negative 25. And this expression as it is. This is a square term, that is a plus 5 the whole squared. And this is 2018. Nice. Now, let us see. If a is negative 5, this thing will be 0. If a is less than negative 5, what would happen is this will be a negative term, and negative squared will give us a positive. So that will increase the value of this expression. Again, if a is greater than 5, we'll get a positive term here, and or if a is greater than negative 5, we'll get a positive term here, and positive term squared is positive term, and plus a positive will give us another positive term which is higher than this term. So the minimum is reached when a is negative 5. When this is 0 and 2018 is not increased by any amount. So what is the minimum possible value? That's just 2018. and that is fortunately one of our options. And to make sure that here a is or x is a real number, we can just substitute this back in. We said that a is x squared plus 5x, so x squared plus 5x equals negative 5, and x squared plus 5x plus 5 equals 0. Okay, so that was some kind of problem here. Now let us check whether x is positive. For x to be positive, the discriminant should be greater than 0. So what is the discriminant here? The discriminant, and that comes straight out of the quadratic formula, which requires a video of its own. That is b squared. Oh, wait a minute. B squared minus 4 times a times c, which is 5. And since it is greater than 0, this means that x is real. And since x is real, it satisfies all our conditions. 2018 is the right answer. And we are done.